Slice them up, look at them under a microscope, they've got reticular fibers, and then they're packed with what two kinds of cells? Lymphocytes and macrophages. Okay? The only difference here is we're not squeezing fluid into there. These things are essentially open to a free surface. You've got a little bump of tissue that's open to a free surface in our mouth or in our intestines. So there's epithelium all around this, producing a little mucus. So whatever gets stuck in that mucus will hopefully end up finding one of these little crypts and go into that. And when it goes into that, now it's essentially in the spider web. Lymphocytes and macrophages can look it over, check it out, see if it's a foreign invader, and try to do something about it. Attack it or start some sort of response. So that's what I meant by the malt and the galt. The tonsils in particular, filters the lymph. Filters the mucus. Filters the mucus. Lymph nodes filter lymph. These filter the mucus. Okay, so remember we studied these in lab before. We saw if you go to the back of the throat and go up, where the back of the throat meets the back of the nose, we have pharyngeal tonsil, also called adenoids. On the back of the tongue, we have lingual tonsil. And then on the sides of the oral cavity, we had palatine tonsil. So all together make a nice little ring. When you breathe in or when you drink or eat, you've got to pass through a ring that's lined with some of this tissue, this malt, mucosa-associated lymphatic tissue. If we look right down somebody's throat like this, I think it kind of hammers the point home a little bit. Hopefully you can tell where we are. Here's the uvula, hanging on the back of your throat. Now we're staring past the uvula at the back of the throat, literally, the pharynx. If we go up under this, we would get up to the nasal cavity, and that's where the pharyngeal tonsil would be. So when you're breathing in air, it can hopefully, foreign invaders will stick in that mucus and then be taken care of by pharyngeal tonsil. But in here, we've got lingual tonsil on the tongue. And then on the side walls right here, see this bulge here and this funny bulge there? These are the lingual tonsils, these are the palatine tonsils. That's what the doctor's looking for. When he or she puts the tongue depressor in your mouth and says, say ah. And they're looking for this view and they're trying to see, are these swollen? Normally, right now, if you're not fighting off any foreign infection or foreign invader, if you just look in the mirror for the same view, you'll just see two arches. Two arches of tissue. That's how we're designed. We have two funny little arches back there. And in between those arches, that's where the tonsils are. If they're not fighting off a foreign invader, they're usually small, and you can't see them. But if they are fighting off a foreign invader, now they bulge into the throat. So it's real easy. You can tell that on yourself next time. You don't have to go to the doctor and stick your tongue out and do it on the mirror. Isn't this kind of a cool shot? Kind of a gross shot. I don't know if you notice, did you see this? And that? That's the salivary glands firing. This person, I guess, had their mouth open for a while, and for some reason, the saliva started shooting through the glands there. Kind of a cool shot. Weird. Okay, so this tissue, by way of little crypts, little slits in the surface, will hopefully filter the mucus. And again, macrophages and lymphocytes. Okay.
They're working properly and they're swelling,
Yep.
fighting. Why would I want to have them removed then?
Great question. If they're working overtime, if they swell for very minor reasons instead of a full-blown infection or something, and they keep swelling, well, any of this swelling is going to be painful to us. So that's it. Is if they're constantly swelling for no real good reason, hack them out. That's essentially what's done. And it's never done to the lingual because that would mess up with swallowing. But palatine are occasionally taken out and pharyngeal are taken out. But that's it. They're just overactive for some reason.
So if you have your tonsils removed, are you more susceptible to
What a great question. That seems 100% logical to me. Because we've now lost part of that ring of tissue there. I've never seen any studies that indicate that, but I haven't looked. So they may be out there. But I would think, to me, it would kind of make sense that, yeah, you don't have as much protection as other people. So I would bet those people might be a little more prone to different little infections. But again, remember, the reason we're taking out is because it's hypersensitive. Well, maybe the other tissue is also hypersensitive and it doesn't matter. They fight it somewhere else. They fight it further down their intestinal tract and it doesn't matter. So I don't know, but it'd be neat to at least look and see. I'm sure somebody's looked at that. I've just never bothered to check the literature on that. It's a good question. nodes. We've done malt and or galt, including tonsils. Let's look at the spleen for a second. The spleen, this is a weird cadaver shot. But what we're seeing here is there's the diaphragm at the top. So heart would be sitting here, lungs over here and here. Right? So somebody's cut the front of the abdomen off. They've taken all the intestines out. So it looks like they left pancreas here. There's a little bit of duodenum there, but there should be a big stomach sitting here. There should be a big liver sitting right here. But they've taken a whole bunch of stuff out. This is such a goofy shot. I don't know why they put this in. But anyways, it's cool that it's real human tissue. But they've removed so much, it's kind of weird. But here's where our spleen sits. It's usually behind the stomach, right up against the diaphragm, right up against the back body wall. So right where you see those ribs 12 and 11 and 10, right in that region. By the way, below, there's the kidneys, each kidney here, which again are a plaster to the back body wall. So you normally can't see any of this when you open up the abdomen. There's so much intestines in the way. They've just cut them all out. So there's our spleen. We also remember when we were studying the autonomic nervous system, we said the vagus nerve would push food from our esophagus down through the diaphragm, into our duodenum, stomach, duodenum, jejunum, ileum, ascending colon, transverse colon, and that's where it stopped. Right? And what was the name of that stopping point?
Splenic flexure.
Splenic flexure. That's where it is. Right? Our stomach's sitting here, and the large intestine goes right like this, bends right there, right by the spleen. So it's a good name. The splenic flexure, where the large intestines bends right next to the spleen. If we look at the spleen, we pull one out. It's not the most exciting looking organ. It's kind of a blind ending organ. We have arteries that bring blood into it. They branch into little capillaries. That blood hopefully gets cleaned up a bit. Then we bring the blood back out through veins. So it's just not a very interesting looking organ at all, at least superficially. But it has some pretty neat functions. Initially, in the fetus, it helps produce blood. I mentioned a minute ago, bone marrow, liver, also spleen. In the fetus, we have lots of ways to make blood. So blood cells will take up residence here and undergo mitosis. Right? In the small kid. As we get older, we kind of lose that function. We don't need it as much. Because our bone marrow has enough of the tissue that we don't have to worry about that. As a young adult and an older adult, the spleen functions as a really neat little reservoir for blood. This is something that's been studied a little more recently. It's not super significant. You saw it's not huge, okay? But because we use this as a filter, we're sending a lot of blood there. I don't know exactly what percentage of cardiac output, but for a small organ, it gets a pretty high percentage. In times of trauma, if we have somebody who's had a gunshot or lost a limb or something like that, they're losing a lot of blood. What has been documented is there's a little bit of smooth muscle in the wall of this spleen. And instead of using its powers to filter blood, it can squeeze. It can take some of the blood that's in there to be filtered and put it back into circulation. So it essentially just says, hey, you need this blood. I don't need to be checking the blood. You need it in circulation. So that's why we say it's kind of a reservoir. So there's a little bit of blood in there. It'll squeeze a bit to keep more blood in circulation if it appears you're losing blood. You know, I don't think it's anything major or significant. I mean, when it's activated, like I said, it's a gunshot wound, it's a lost limb. That's not enough blood to really account for it. But it just shows you the body's trying to do something. Kind of one side there. We don't have to filter right now. We're hopefully trying to stay alive. So it's probably under sympathetic control. Right? We get real excited because we're losing blood. So some of the smooth muscle in the wall of this organ will squeeze to keep blood from going into the filter. Right? Okay, but back to day-to-day operation. I keep referring to it as a filter, a lot like the liver. But one of the things that the spleen is really good at is filtering out dead blood cells. Dead blood cells. We said in lab that a red blood cell will only live about, what did we say, 6 weeks, I think? Something like that, 5-6 weeks. Okay? So we have to constantly make new ones, but we also have to get rid of the dead ones that are in circulation. So the spleen seems to be especially good at that, at clearing our blood of dead blood cells. For some reason, the lymphocytes and the macrophages in there are really good at picking them out. The spleen is not a vital organ, though. As weird as that sounds, you'll see patients all the time who fracture their ribs and lacerate their spleen, and the doctors will just go in, and it's a simple organ. All you got to do is tie off the blood vessels and hack it out. It's easy to get rid of. So very often, surgeons will go ahead and just take the spleen out in an adult. In a kid, they usually try to leave it. But in an adult, they'll take it out. Because our liver will still take over the filtering function. Okay? So what happens in those patients, you can almost tell when somebody's had their spleen removed in the last couple of years. Because when you look at their blood under a microscope, we have somebody going into that. Is it Aaron? Who's doing medical lab science? No? Okay. Thought we had somebody in here. But when those people look at a blood sample, they see a higher percentage of dead cells. It takes a little time for the liver to realize that it has to take those cells out of circulation and kick in. So sometimes you can actually just look at somebody's blood and tell their spleen's either not there or not working properly, because this is a pretty big function, RBC disposal. But liver will take it over eventually. And
when you have mono, is that what they worry about?
Yep, definitely. Is the spleen is one of those organs that can really swell up. When we have mononucleosis, we have problems with some of our monocytes. So, yep, this is one of those organs that can really swell up. And in that case, it's usually a bad sign. It's not just that it's working, it's that we've got kind of a more advanced stage of mono. Okay. So, I'm sorry, Lauren.
I mean, with mono, why does it make someone tired? Why is that one of the side effects?
I don't know. I don't know if I'd call it a side effect. That's a main effect, from my understanding. But it's affecting your blood, so I'm going to throw that out there. I don't know. I haven't really looked into mono that much. I was lucky and never got it myself. But when I look at mono, it's affecting your blood. Anything that affects your blood is going to affect oxygen transpiration. You're just not going to have a whole lot of energy. So I'm going to throw that out there, but that's probably not the best answer for it. Okay, so day-to-day function, red blood cell disposal, and then obviously the standard stuff. If you cut into a spleen, it looks just like a lymph node. You almost can't tell them apart. If you get close enough down, like that scanning EM picture I showed you a minute ago, you can't tell them apart. There's reticular fibers everywhere like a web. Then there's macrophages and lymphocytes hanging out. Okay? If we look at it a little further back with a light microscope, you can tell the difference. If we look at this image here, hopefully you can kind of tell, well, there's this funny little artery area, a couple of arteries, and the tissue around it looks different than the tissue up here. We talk about red pulp versus white pulp in here. So, at 400x, you can tell them apart. But at 1000x or 2000x with scanning EM, it's just spider webs. Spider webs with macrophages and lymphocytes. So I'm not going to ask you to identify them. I just wanted to kind of point it out. There are some differences, but if you get really right down to it, they're all the same. Tonsils, thymus, spleen, lymph nodes, they all look the same because they all basically have the same function. All right. Okay, so there are some of the major organs. Just hitting them in a little bit of detail. What I'd like to do is give you, spend today and Friday going over what I would consider my version of defenses. The defenses. So again,